Hi, my name is Mr. John. I welcome you to my study room. Today, our study is about finding the gradient of a tangent to a circle. Finding the gradient of a tangent to a circle. Please pay attention and let's go through this lesson together. Thank you. Before we go ahead to find the gradient of the tangent to a circle, I want to just say that I already have a video about the relationship between a circle and the tangent to the circle, and the link is what I'm sharing with you at the top right now. You can just watch if you want more explanation about the relationship between a circle and the tangent to a circle. But that notwithstanding, I would like to say these very few things about the relationship between the tangent to a circle and a circle before we go ahead with the calculations, because these are going to help us do the calculation. So the very first thing I would like you to know about is that the tangent to a circle is any straight line that touches the circle at one point only. And the second thing I would like you to know is that this straight line we are calling tangent is perpendicular to the radius of the circle at a place called the point of tangency. And this point of tangency is just the point of contact between the radius of the circle and the tangent. This is just where the two of them are just meeting the circle. Like I said, I don't want to spend so much time on this because I already have a video on this and the link I've shared already. So at the point of tangency, the radius of the circle and the tangent are perpendicular, meaning the angle between them is 90 degrees. And because of this relationship between them, the gradient of the tangent can be known if we know the gradient of the radius to the circle. Yes, because they are perpendicular, and we've studied, I have videos which show that when two lines are perpendicular, the product of their gradient is -1. So it means that the gradient of one of them is a negative reciprocal of the other, and we will be demonstrating that as we go ahead with the calculation. These are the few things I would like you to know about before we go ahead with the calculation. Number one, the fact that the tangent to a circle is a straight line that touches the circle at only one part. And the second point, the fact that the tangent and the radius to the circle are perpendicular at the point of contact or point of tangency. And because they are perpendicular, the product of their gradient is -1, or the gradient of one is the negative reciprocal of that of the other. I would like to take us through a few steps we need to follow if you want to find the gradient of the tangent to a circle to guide our calculation. So let's take those steps quickly. So here we have the steps. Step 1 says obtain the center of the circle as C with coordinate x1, y1. And step 2, identify the point of tangency as P with coordinate x2, y2. Step 3, find the gradient of the radius CP, which passes through x1, y1, which is the center, and x2, y2, which is the point of tangency, as M1. We decide to call the gradient of the radius M1, and we just use the gradient formula, the change in y over change in x. Then the step 4 says that the gradient of the tangent is the negative reciprocal of the gradient of the radius. That is, gradient of the tangent, which we decide to call M2, will just be the negative reciprocal, which is 1 over M1. Let's take one example to see if we can follow these steps to solve. Our example says find the coordinates of the center of the circle whose equation is x2, y2 plus 6x plus 4 equals 0. Then the B part of the question says we should show that the point T with coordinate -5, -1 lies on the circle, and the point C says we should find the gradient of the radius CT and hence deduce the gradient of the tangent t. Right. I must say that this question, the way it is put, it already explains our point one by one for us. So we just have to follow the questions, then we go. So our first thing will be to solve the A. We have to find the center of this circle. So let me write the equation of the circle again. I already have a full video on how to find the center of a circle when the equation is given. So, and I'm sharing the link with you at the top here right now. You can just check that if what we are going to do you have challenges with it. So because of that, I'm not going to do too much explanation since I have a video on it. We are just going straight to find the center of the circle. To find the center of the circle, we have to compare with the general equation of a circle, which is x squared plus y squared plus 2gx plus 2fy plus c equals 0. Alright, so by comparing, 2g will give us 6. Dividing both sides by 2, g will be equal to 3. And then 2f will give us 0 because we don't have the y terms here. So that is 0. And dividing both sides by 2f will be equal to 0. And from what we have done in circles so far, the center of the circle C will give us negative g, negative f, and that is negative 3, 0. So this is the answer for our A, finding the coordinates of the center of the circle. So now we are going to the B, where we are going to show that the point with coordinate negative 5, negative 1 lies on the circle. Before that, let me just write my circle again and then write the coordinate of my point to negative 5, negative 1. I already have a full study or video on how to check if a point lies on a circle or not, so I'm not going to say much. The link I'm sharing with you right now. So that one, we are going to have negative 5 squared plus negative 1 squared plus 6 times negative 5 plus 4 equals 0. This is 25 plus 1 minus 30 plus 4 should be equal to 0. 25 plus 1 is 26, minus 30 is negative 4, plus 4 is 0. So 0 equals 0. And since this point satisfies this equation, we will conclude that therefore this point lies on the circle. Let me go to our question C. Find the gradient of the radius CT and hence deduce the gradient of the tangent at T. The center of our circle is negative 3, 0, and our point of tangent T is negative 5, negative 1. Alright, so the radius of the circle is the line joining the center and these points on the circumference. And we know that the gradient of a straight line is a straight line. So we are going to use a formula for finding gradient of a straight line to find. And that's changing y over changing x. Maybe for us not to make mistake, let's call here x1, y1, x2, y2. So the gradient m1, let's call it m1, is going to be negative 1 minus 0 over negative 5 minus negative 3. This will give us negative 1 over -2, which will be equal to 1/2. So this is the gradient of the radius to the circle. Then the question says we should go ahead and use this to find the gradient of the tangent to the circle. And from our point, we said that if the gradient of the tangent to the circle is m2, then m2 will be equal to -1/m1. So that's just what we are going to do. This is our m1, and the reciprocal of this is 2/1, which is the same as 2, and we are going to negate it. So the gradient of our tangent is, let's just conclude, therefore the gradient of our tangent is -2. And this is where we bring today's lesson to an end. I hope this lesson has been of help to you. You can now determine the gradient of the tangent to a circle if you know the equation of the circle and the point at which the tangent is touching that circle. So this is how we find the gradient of the tangent to a circle. I hope this lesson has been of help to you. If yes, why not hit the subscribe button so that anytime I post a new video, you'll be updated. Thank you for making time with me, and I hope to see you again in my study room. Bye bye.